At 63 degrees north, Trondheim spends much of the year plunged into polar night. Surviving here means fighting sub-zero temperatures and near-total darkness. Yet sitting right on the harbor is Powerhouse Brattørkaia. By all conventional logic, a building in this climate should be an energy drain. Instead, it is the world's northernmost energy-positive office building. Over a projected 60-year lifespan, this structure will generate double the energy it consumes. That calculation includes the energy required to manufacture its materials, build it, run it for 6 decades, and eventually demolish it. The primary engine driving that surplus is visible from above. Nearly 3,000 square meters of solar panels blanket the roof, generating up to 500,000 kilowatt-hours of clean energy a year. Operating as a power plant in a region that barely sees the sun for months forces architects to discard standard building design entirely. 600 people report to work here every morning, filling desks across 4 floors of open-plan office space. But look at the ceiling above this conference table. It appears disjointed. The white panels are scattered unevenly, leaving large, irregular gaps that expose the raw concrete wiring above. Why would Snøhetta, the elite architectural firm behind this project, design a 60-year environmental masterpiece, only to leave the interior looking like the contractors walked off the job early? This visual disorder is actually a byproduct of the building's core physics, a calculated attempt to solve a conflict that a standard uniform drop ceiling would only make worse. This cross-section illustrates thermal mass. By leaving the concrete ceiling exposed, it becomes a passive thermal battery. During the day, it absorbs heat from people and computers. At night, it releases that stored heat back into the room. But 600 people working in an open-plan office generate a constant wall of noise. Without heavy acoustic dampening, sound waves bounce off the hard concrete, making the space unusable. A traditional acoustic ceiling absorbs noise, but acts as an insulating blanket, physically blocking ambient heat from reaching the concrete battery above. The engineers faced a harsh trade-off: build a quiet workspace that constantly overheats, or a perfectly climate-controlled building that is deafeningly loud. To solve this, a specialized contractor named Valtech designed a matrix of suspended acoustic baffles. The chaotic, uneven spacing is the exact output of advanced computational fluid dynamics modeling. This simulation shows how the design works. The baffles provide the precise minimum surface area required to trap bouncing sound waves. At the same time, the gaps are specifically plotted to let heat currents flow seamlessly up to the concrete. The installation is highly zoned. In the center of the building, where the cooling need is lower, the baffles are packed densely to control noise. Near the windows, where thermal regulation is critical, the concrete is left almost completely exposed. That messy ceiling is a highly tuned, 3-dimensional physical map of invisible airflow and sound waves. This strict adherence to environmental physics dictates the rest of the interior as well. In specific common areas, massive sloped black ceilings intersect with the exposed concrete pillars. These dark angled surfaces are custom engineered to integrate a specialized liquid light system. This specific geometry cuts the building's lighting energy consumption by 50%. These aggressive design constraints yield hard data. The building achieved a BREEAM Outstanding certification, placing it in the top 1% of sustainable buildings globally, and maintains a net energy balance of -4.9 kilowatt-hours per square meter. They secured those environmental metrics without sacrificing the acoustic comfort or functionality for a single human worker inside. Designing for an energy-positive future goes deeper than the visible solar panels on the roof. It requires rethinking the most mundane, hidden elements of our interior spaces. Every single panel, baffle, and gap you see in this building serves a strict thermodynamic purpose. At Brattørkaia, form no longer follows function. The form is the function.